My name is Captain Ashley Kessler. I'm on the teaching staff at San Jacinto College, Maritime Technology and Training Center campus here in Houston, Texas. This is part 3 of radar plotting. This time we'll be giving a known new course or known new speed, and it'll be a second triangle. You need to have a solid understanding of part 1 of my radar plotting series here on the basic radar triangle to complete this video. The objectives of this course are, at the end of this presentation, you will, 1, be able to construct a second radar triangle with a new known course, then determine a new CPA and bearing of CPA. Second, you'll be able to construct the second radar triangle with a new known speed, then also determine a new CPA and bearing of CPA. Known new course to steer. In part 2 of the video series, we found out what course we needed to alter to in order to maintain a required CPA. In this video, we're going to be given a new course. So when the contact tracks down that relative motion line, they get to the execution point or MX, we'll alter course. So the problem here is we want to alter course to 0.55 degrees when the contact is 5 miles away. What will the new CPA and bearing of CPA? Here's our basic radar triangle. Our own ship is going due north. The contact is heading west. The execution point or MX is at 5 nautical miles. We want to alter course to 0.55 degrees when the contact gets to MX. But first we need to change the triangle before we can deal with MX right now. So we have a line of a true 0.55 course, and we want to parallel this 0.55 to E. E 0 knots. E is always the beginning of our true course and our true speed or our true motion. So our original course was due north, and our new course is going to be 0.55 degrees. So let's change course. Let's get your compass, stab E, and swing R00 to starboard. And this is R prime. If I change course on the relative motion radar, I change relative motion. If I alter course to starboard, it's going to make them look like they alter course to starboard. So the old relative motion line was R00 to M06. The new relative motion line is going to be R prime to M06. Then we're going to parallel that down to MX. And that's my new relative motion line. From this new relative motion line, I can get a new CPA, a right angle from this new relative motion line to us in the middle of the plotting sheet, and a new bearing of CPA. So since each range ring is 2 miles, looks like they're going to miss this little over 2.5 miles, almost 3 miles, and the new CPA bearing is going to be 3.45 degrees. A known new speed. In video 2, we did not know what speed to alter to maintain a required CPA. This time we know what speed we want to alter to. So we want to slow to 12 knots when the contact is 5 miles away. What will be the new CPA and bearing of CPA? Same problem that we had before. Our own ship's still heading due north. The contact is heading west. MX, or the execution point, is at 5 nautical miles. We want to alter speed to 12 knots. So we need to come over to the 12-mile scale, and we need to measure 12 knots. So we want to measure 12 knots at E. If you know the speed, you go to E. That's the phrase I teach my students. If you know the speed, you go to E. If you know the course for speed, you go to E. And at the end of that 12 knot vector is going to be our R prime. If you change speed on the relative motion radar, you change relative motion. So our old relative motion was R00 to M06. Our new relative motion line is going to be from R prime to M06. Then we parallel that down to MX, and we can get a right angle from the relative motion, that new relative motion line, and a bearing of CPA. So we're going to miss about approximately 3 miles with a new CPA bearing of 345 degrees. To review our objectives, in this presentation 1, we constructed the second radar triangle with a new known course. Then we could determine a new CPA and bearing of CPA. Second, we constructed the second radar triangle with a new known speed. Then we did determine the new CPA and bearing of CPA. If you have any questions about this video, you can email me to my campus email at ashley.kessler@sjcd.edu.